So many power-constrained devices are also connected devices. And one thing that's sometimes misunderstood is when you're developing your power budget for the system, that a lot of the power is consumed by the device, whereas in fact a lot of it is consumed in transmitting data remotely or to the cloud. In fact, an overall system power budget, you can, if you do the processing on the device in a very low power way, that's probably the best way of reducing the power rather than transmitting lots of data to the cloud. I'm Paul Bearpark. I work for 42T. 42T is a technology consulting and product development company based near Cambridge in the UK. We exist to develop innovative products and processes for our clients to help keep them competitive. When we develop power-constrained products, such as battery-powered products, we often find that there is a trade-off between performance and power. Traditional microcontrollers do have low power modes to help with power consumption, but we still think that there is a trade-off that often needs to be made, and there are compromises that need to be made, and those often involve reducing duty cycles, curtailing precision, and may even involve rejecting particular sensing modalities, especially where those sensing modalities consume a lot of power. We have a long track record of developing condition monitoring systems for our clients. These range from industrial gas bottles to electricity substations to detecting leaks in pipes. However, there's still an unmet need for always-on low-power condition monitoring, especially where there is no mains power available or where that mains power may be inaccessible. We identified the Innatera Neuromorphic processor as a potential solution to some of these applications, and we have spent some time understanding the tool chain for the prototype chip and did some initial training on that chip. When the production pulsar chip became available, Innatera helped us with the port of our code base from the prototype chip to the production chip. Together we have developed an application that does always-on condition monitoring of a sensor that reports on the state of a motor and its condition, and also how it responds to different loads. Initially, we are intending to report on anomalies, but in the longer term we hope to be able to characterize specific failure modes and also predict failures in the future before they actually happen. And these sorts of condition monitoring applications will be useful in industrial settings, in factories, but also in remote places. For example, in the water industry, where a lot of infrastructure is remote and failure could be quite disruptive and costly, but also in the consumer sector as well, where you want to ensure that people's devices are operating well and to inform them if something is likely to fail before it fails.